Okay, so today we're starting a new unit. Compositions of functions is where we're starting day one of trigonometry. So we're going to start, this is the big start of really important stuff here, trigonometry. So we're going to do compositions of functions first before we start that. This is some algebra background. Okay, so I'm going to start here with functions. Okay. All right. So to start off, compositions of functions, you really have to understand the basics of functions. All right. So most of you are probably pretty comfortable and you might think this is super easy, but when you start putting a function in another function, that's where people get confused. So we just have to realize it's still the same thing. So if you have a function, most of you understand f of x is the same as y, right? So x is your input. F of x is your y or your output. Okay, x is in, y is out. That means when you say, here's your f of x right here, x plus 2, I did a real simple function. So if you are putting in 0, that's your input. That means everywhere you have an x, that's your in. That is your in. Okay, so you're going to be putting in a 0, okay, plus 2, which equals 2 on this one. Okay, the next one you're going to input whatever your x value is. So it will be 1 plus 2, right? There's your input, plus 2 equals 3. So you got to get the hang of this, okay? I know this is obvious. Your input is now 2, so input plus 2. So 2 plus 2 equals 4, etc. So you're getting the idea, right? 3 is your input now, plus 2 equals 5. Okay, now what if I put in a function as my input? It is the same exact thing. You are putting your function in, okay? And there's your input, okay, plus 2, whatever that is. What if I put an apple in there? A nice, whoops, go away. Nice little green apple. Then it would be input. Oh boy, my pathetic drawing stills. Input plus 2. So here's the magic formula. F of x equals y. This, whatever is in here, is your input. Okay, so if you do f of g of x equals x plus 2, right? That's your function right there. You're going to take this, that's your magic input, and you're going to put it in everywhere there is an x into your function. This becomes your input, right? If you did f of 4, that would become, there's your function. You would take that 4 and stick it into your x. Same idea. If you have another function, you put it into the x as your input. Okay? So let's do some practice problems right now. Go back to some normal color pens. All right. Let's practice here. Give myself some room. All right, so here we go. We have two functions here. We have f of x is equal to x cubed, and we have g of x, which equals 5x plus 1. Okay, so when you see this notation here, this stands for f of g of x. I would prefer if you would rewrite this whole thing like this, f of g of x. That big way, it becomes very apparent that g of x, see, it's just in order, f of g of x, f of g of x. G of x becomes now the input, that's your input, into your main function, f of x. Okay, so what is f of x over here? Let's write it out. Here's f of x. F of x is equal to x cubed. And we're going to put, so if we have f of g of x, we're going to input g of x into that x cubed there. Okay, so it will become, here's your x input cubed. So that g of x goes in here, 5x plus 1. Input, right? Input cubed, like that. Okay. All right, so let's try another one. Let's try g of f of x. Again, I would prefer if you rewrote that, just in order of how it's written there, g of f of x. So now it's really obvious that f of x is your input into g of x. You're putting in f of x into g of x. So let's write g of x over here. G of x is equal to 5x plus 1. So g of f of x, okay, you're going to input that f of x everywhere you have an x in the g over there. Okay, go away. So my screen doesn't want to go away. Okay, so that becomes 5 times, what is f of x? X cubed. Right? That is the f of x right there. Right? So 5 input, which is f of x, plus 1. Okay, so if you simplify that, if you clean it up, so it would equal 5x cubed plus 1. Okay? Now let's look at this. You can do f of x. So let's rewrite that the way I like to see it. Actually, it's f of 2. So in order, let's do that. F of 2. Okay, so now this is the input. F is inputting into itself. So first you can do f of 2. Let's do f of 2, work inside out. So let me write that so you see it. Inside out. Okay, work inside out. All right, so let's do f of 2. Sorry, black pen. So f of 2 would be, what's f would be, right, x cubed, right? So here you would put the 2 into that x right there. So it would be 2 cubed, which equals 8. Okay, now this becomes f of 2. Let's substitute that back out now. This f of 2 becomes f of, right? You just calculated f of 2 equals 8. So you could substitute f of 2 with 8. So now it becomes f of 8, which f of x, okay, is equal to x to the third. And instead of x, you have, right, your input is 8 here, right, f of 8. So you're going to stick that 8 in everywhere you see an x. So it's going to become 8 cubed, which is whatever, 8 times 8 times 8. Okay. Let's try some more. We need to practice these, okay? So work inside out when you have those. So substitute in the 2 into f of x in the beginning. Okay, I'm just going over this here. Substitute in your 2 here in the beginning into f. After you get f of 2, then you know that equals 8. Then you just do f of 8. All right. Let's try another one that's a little more difficult. Now we're going to work with some compound fractions. So this is really important because we're not getting rid of fractions. So let's now work with a couple of these here. So first we have f of g of x. Here's your f. Here's your g over here up at the top. So let's rewrite this as f of g of x, just like we did before. So now it becomes obvious that this is your input, that's your in, and this is your main function. Okay, so I'm going to write f of x over here. So we're going to have 3 over x plus 7. And into this, we are going to put g of x into that x right there. Okay. So that's going to become 3 over input, which is, there's g of x up here, 4x squared plus x plus 7. Okay. So this right here was your g of x. Okay, so you can simplify that whole thing there, clean it up, right? It doesn't have to look so obvious, so ugly. 4x squared plus x plus 7. And just by way of talking about this, remember your denominator is never equal to 0. So you would have to find out what x would make this equal to 0 here by solving the quadratic factors. Okay. All right. So let's try another one here. G of f of x. So I'm going to rewrite that so cleanly. G of f of x. So this now is the input into g of x. Okay. So let's write g of x. Okay, so let's write g of x. So that's 4x squared plus x. So into that, you are going to put, you're going to input f of x. That is our input over here into g of x. So that will become 4 times 3 over x plus 7 squared plus 3 over x plus 7. Okay, so we need to clean that up. Here we go with some fractions. Okay, so 3 squared over here. So 3 over x plus 7 squared. So that's 4 over 1 over times 3 times 3 is 9. And then x plus 7 squared plus 3 over x plus 7. And then you need a common denominator, which is x plus 7 squared. That's the most difficult one, right? This one is missing a factor of x plus 7. What am I multiplying by? This magic number right here is equal to, magic number, right? 1. That is just equal to 1, anything over itself, okay? So I've run out of room here, but this just becomes 4 times 9 is 36 over x plus 7 squared. I can write it over here. 36 over x plus 7 squared plus, now distribute this 3x plus 21 over, and now x plus 7 times x plus 7 on the denominator becomes x plus 7 squared. And now that you have the common denominator, you can combine the numerator there. Okay, boy, I'm running out of room. I'm running out of all kinds of room there, but it's 36 plus 21 plus 3x over the common denominator of x plus 7 squared. Okay, let's do one that's just a complicated fraction, and then we'll call it a day with this. Okay, so let's do the last one, which is this one right here. Okay, move this up so we have a lot more room. Okay, compound fractions. So here we go. Complicated, yucky fraction. So here's our two functions, f of x and g of x, a fraction and a fraction. So we're going to do f of g of x. So again, rewrite that f of g of x. So again, here is our input, okay, into the input into f of x. So we write f of x is our main function, and we're going to input g of x into it. So let's rewrite f of x. Okay, so I'm going to write 5 over 3x plus 2. And then here we're going to input that g into that x right there. Sorry, go away. Okay, so let's rewrite that now, which becomes 5 over, look at this, input 4 over x minus 1. That's what that x is right there, right here. We input g of x into that x plus 2. Okay, so that right here, so in case you have any doubt, that's a g of x right there. Okay, that we input. All right, now it's fraction work. So this is what we need to master a little bit. So I'm going to start over here, maybe a little tinier. So that 3 is the same as 3 over 1, so there's no doubt. And then 4 over x minus 1 plus 2 over 1. Okay, so what you have here, I want you to pay attention. This is the main numerator, 5, divided by an ugly fraction. We don't need to be mixing up like this numerator with this over here, okay? It's 5 divided by that mess down there. Okay, in other words, when we have, I'm going to write off a little thought bubble over here, a real dumb fraction over here. If I had something like this, 5 over x over 2 over y. It is not, sorry, let's do another example. Over, go away, over 2. It is not 5 over x over 2. Do you see what I'm saying? You have to determine where is the main division point. Is it 5 over x over 2, or is it 5 over x all divided by 2? Which one is it? So be careful when you're doing this. Make sure you know where the main division sign is, because when we do all these compound fractions, it gets nasty sometimes. Okay, so let's go back to our main one here. Sorry, I went off on a tangent with that. Okay, so here we go again. So we have 5 on the numerator, and that's 3 over 1 times 4 over x minus 1 plus 2 over 1. Here we are over here. So that whole thing reduces. So that's 3 times 4 is 12 over x minus 1 plus 2 over 1. How do we get a common denominator there? Again, this is the denominator, x minus 1. That's the common denominator. So we're going to multiply this by x minus 1 over x minus 1, which is our magic number, right? 1, la, la, la. Okay, it's our magic number 1 right there. So let's keep going. Again, this is over that whole thing there, right? Not to get confused. So 5 over, now we have a common denominator, 12 plus 2 times x minus 1 all over x minus 1. Because when you have the same denominator, again, let me do a little thought bubble over here. I'm going to go off in the on a tangent. I'm going to erase this part here. Okay, I'm going to do another thought bubble up here. Go away. Okay. When you do a common, let's just do a regular fraction, right? X over 4 plus 2 over 4 is equal to x plus 2 over 4. Okay, so when you have the same denominator, you can combine them, the numerator there, okay, into one thing. All right, so that's all we did down here is we got a common denominator and then we can combine it like that right here. All right, this fraction's going on forever, right? So here we go. So it's 5, excuse me, oh my gosh, late. 5 over, now we have 12, let's distribute this here. So that's plus 2x minus 2, all divided by x minus 1. So that would equal 5 over 10 plus 2x over x minus 1. So I'm going to rewrite that over here, and now we're going to do a little bit of the magic here, okay? So that 5 right here, I'm going to change that to 5 over 1. And then we have our main division thing here, right? And then we have 10 plus 2x. Let me move this whole paper up here. Okay. And that's divided by x minus 1. All right, the reason I did that is because I'm going to get rid of, this is called a compound fraction when it's a fraction divided by a fraction. So I'm going to get rid of that by multiplying by the reciprocal of this. And now that looks pretty wonky for a fraction. So because like now what Miss B, that looks really bad, doesn't it? But here's what I'm going to do. I'm going to do the same exact thing in the numerator. So it is x minus 1 over 10 plus 2x. Okay, go away. Because here again, here's the magic. Look at this whole thing. Look at that whole thing right there. See all the magic stars? X minus 1 over 10 plus 2x divided by x minus 1 over 10 plus 2x is equal to our magic number, 1. This is anything divided by itself right here. This whole thing here is just equal to 1. Okay, so you're actually not changing that fraction there. You are just multiplying it by the number 1. But by doing that, look what happens. This cancels with this. And this cancels with this, right? X minus 1 over x minus 1 cancels out. That's equal to 1. And 10 plus 2x divided by 10 plus 2x, that's equal to 1, which leaves you with 5 over 1 times x minus 1 over 10 plus 2x. And there, now we got rid of that whole giant denominator right there is all gone now. So now you can just write it as a nice clean fraction. And there is your final answer. And again, the denominator is never equal to 0. Okay, so what would make that equal to 0? Work it out. So 2x cannot equal negative 10. Divide by 2. Let's move that up a little bit so we can finish this off. So x cannot equal negative 5. And there we go. So that's that. That's the domain. It's the real numbers, but x cannot equal negative 5. Finish.